Welcome back to Transcended Stud Hub. In today's tutorial, we are going to talk about how to solve some practice questions under physics that is for preparation of the exam. So I have solved a lot of questions in this 2024 past paper, and I would advise you to just take a piece of paper and a book, try to solve before you see how I solved it, so that you compare the answers. Okay, let's begin with question 2. So now this is question 2 of the paper for Physics 1010 2024 exam past paper. So the question is saying a ball, that is part a ball at the end of a 2 meters long string swings in an arc as shown below. The ball speed is 3.5 meters per second as it passes through its lowest position. To what height h above this position will it rise before stopping? Part 2. What angle does the string make with the vertical when the ball is at the highest position? Now, it is very important for us guys to first look at the diagram which have been given. So this is more like a simple pendulum, but we need to understand some certain concept. So the first thing I want you to understand is that this length which have been given here, the length which have been given is 2.0 meters. Now this 2.0 meters is this one which you have there. But at the same time, if I can take this, I bring it back, it is basically the same as this length. So this is also L. Everything from there all the way to that position. Okay? Meaning that for me to find this part here, it's going to be L minus h, of which I don't know h for now. So let's get this to be x, meaning that for me to find x is going to be what? For me to find x is going to be L minus h. But the first question is asking us to find the h. So let's go. Now, one thing again we need to know and understand here is that we want to find the h. The question there is saying the ball speed is 3.5 meters per second as it passes through its lowest position. Lowest position is this position. So as it was passing this position, the speed is 3.5 meters. Okay? The speed is 3.5 meters as it was passing here. Then when it reaches there, it came to stop. It was just there. And that's where now we have got the distance, the height. Meaning that at this point here, we have kinetic energy. We don't have potential energy at that point because it was moving and the height is 0 at this point. So if you want to make things simple, you can say this is point A and that is point B. So at point A, we expect to have only potential kinetic energy because the ball was moving at that point. And it is at the lowest position, h is 0. So we expect to have potential kinetic energy only. At point B, it was not moving, but there is height, meaning we need to have what? Potential energy at that point. So therefore, you say kinetic energy at point A should be equal to the potential energy at point B. That is conservation of energy. Conservation of energy. So conservation of energy is that energy cannot be created and it cannot be destroyed, but it can be converted from one state to another. So the energy which we have here, when it reaches at point B, is going to be converted to potential energy. So I'll say half mv squared being equal to mg h. We do not have mass, we can cancel mass, or mass appears to be everywhere. So my goal is to find the h. Half v squared is equal to gh divided by g divided by g. So h will be equal to half v squared you divided by g. So h will be equal to half. The velocity is 3.5. Now we square it. We divide it by 9.8. So what will be h? So if I go back here, I find my h, discover that I will have 3.5. I square it, times 1 over 2 is 0.5. I divide it by 9.8. So I'm getting my h to be 0.625 meters. If you want, you can round it off and say 0.23. It's okay. That is just fine. It's alright. You can do that. So that's the answer for the first part. Now we move to the second part. So the second part now, we can clearly see that it's asking us to say what angle does the string make with the vertical when the bow is at the highest point. So when the bow is here, what angle? So now here, one thing we should know is that I'm going to use SOHCAHTOA. So we definitely know that this is the hypotenuse, this is the opposite, the angle, and this is the adjacent. So I have the adjacent because for me to find x, adjacent is x. So for me to find x, it's definite L, which is 2 minus h, which is 0.625. So my x is so I do minus 2, my x is 1.375 meters. So which one am I going to use? Not for the opposite, but I'm going to use cos, because cos is adjacent over hypotenuse. I don't know opposite. So opposite, if you want, you can also find using Pythagoras theorem, but it's going to take time anyway. Okay, then when you find the opposite, you can use tan if you want. You end up having the same one. So in this case, I'm going to use cos. So I'll say I can now get rid of this. I'm going to say cos theta is equal to, what is cos theta? Cos theta is adjacent divided by hypotenuse, of which we know that adjacent is x. I divide this by the hypotenuse is L. Now my goal is to find the theta. I'll divide both sides by cos. So therefore theta will be equal to cos inverse of x divided by L. I want you to know this. When I divide this side, it will be like this. X divided by L times cos times 1 over cos theta. So 1 over cos is the same as cos inverse. That's why I've put cos inverse here, in case you don't know. Now at this point, I can now plug in the values. So I'll say the theta will be equal to cos inverse. My x is 1.375. My L is 2. So let's see what will be our theta. So shift, then cos, open brackets, 1.375. Then I divide this by 2. Okay, so the angle I'm getting is 46.567. 46.5 46.567 degrees. To make things simple, let's just round it off. So it's 46.6 degrees. That's the angle. So that is it for question 2a. So it's just a matter of you understanding what is happening, and it's very easy. Okay. So now, in this one, we are going to solve question 2b from the same paper, Physics 1010 2024 exam. So this question, I've solved it before, but let's try to solve it again. So the question is, a stone is thrown at a vertical or at a velocity of 21 meters per second at 30 degrees above the horizontal from the top of the building, 16 meters 16 meters high as shown below. Find part A, the time of flight, part B, the horizontal range, part C, the maximum height h from the ground. Now, one thing we should understand, guys, is that this projectile motion question is coming from the third case. The combination of the first case and the third case, or and the second case, gives us what? The third case. Now, let's try to understand something. Okay? I know to say maybe you know that other formula for finding the time, the complicated one, for using a quadratic equation. But in here, I'm going to show you the simplest method on how you can find the time in the third trajectory. Okay. One thing we should understand is that from this point here, this is basically the second trajectory. Okay. And you are going to find, you also have the h. I will denote that one as small letter. And you also know that from this part here, if this is the case, we do have another case, which is case 1. So the combination now, I want you to understand that from this point here, let me denote this to be A, I will denote this to be B, I will denote this to be C. We should understand that for me to find the time from point A to B, that is the second trajectory. So it comes from this formula where we say V final is equal to the V initial plus GT. Now, we are talking about Y component. It is moving in Y direction. When it reaches at B, the final velocity is 0. It is going against the gravity, G will be negative. So we are talking about V sine theta minus now GT, because G is negative. Shift this to the other side, it will be negative V sine theta. This, I want to find the T divided by negative G, and therefore the T from A to B, it will be given by V sine theta divided by G. This is the time from A to B. Okay, so I'll write it here. Time from A to B is V sine theta I divided by G. Now, another thing which we have to take note here is this. The time from B to C, that is now free fall. So we are starting from this point where the final velocity or the initial velocity is 0, because we are starting from this point. At this point, the final velocity was 0. Now that is going to be my initial speed, because that's where I'm starting from. So I have got the whole of this h. So the second equation of the motion is going to work, where we say the displacement is equal to V initial times t plus half gt squared. But we should note that the initial speed is 0. This is going to be cancelled out. S is h. Okay, so I end up having this. But my goal is to find the time. I will do times 2 everywhere to get rid of the fraction to the other side. So if I do times 2, it will be now 2h being equal to gt squared divided by g divided by g. Therefore, t squared will be equal to 2h divided by g. I can get the square root, so t will be equal to the square root of 2h divided by g. So this is now t from B to C, being equal to the square root of 2h. This h is the maximum height from the top there all the way to the ground. Okay, divided by that. But you know what? You can't find, one thing I want you to, before we even continue here, you can't find the time without finding the maximum height. And part C is asking us to find the maximum height, meaning that I can first go ahead and find the maximum height, which is part C. So before I even find the time here, I can go back and find the third one. So the third one, I want to find the maximum height. So the maximum height, I already have the height from this point all the way to that point. I just need to find the height, which is this part here, this height. So that height, I'm going to denote it with small h. So the second trajectory now, if I have this, let me just do it from here. So I'm trying to find this h. Okay, now to find that h, one thing we should know that it's going to be thrown. We have been given an angle here, we know that. Then we have the initial speed. So the third equation is going to work. V final squared is equal to the V initial squared plus 2gh, because h is now d. One thing we should note is that when it reaches at the maximum height here, the final is 0. So this guy is 0. So we have the initial. Now this initial, since we are talking about y component, it's going to be Vy, but it's going to be V sine theta, but it is squared. Now g will be negative, meaning this is going to be negative now, like that. Shift this to the other side, you have this. I'll have negative 2gh. My goal is to find the h. I'll divide both sides by negative 2g, negative 2g. So these will cancel. H will be equal to V sine theta, negative and negative will go. I divide this by 2g. I'll use this formula, but some other people, what they tend to do is that it's basically the same as saying h is V squared sine squared theta divided by 2g. It's the same thing. It's basically the same thing. So I need first to find, now for me to find the capital H, the capital H is as a result of the addition of 16 plus h. The h which I need to find using this formula. Okay, that is the h which is going to help me now to come there. So I'll do this. I'll get rid of this to find the small h. There we go. H will be equal to, what is my v? My v is 21. Okay, sine the angle is 30, so this has to be squared. Remember, if you want, you can do 1 you square sine and you square 21, but the best way for you not to make any mistake, just square everything together. So we have 2 times 9.8. You should take note that under projectile motion, we do not get g as negative, because when you are driving the formula, we have already dealt with that one. Okay, so the g is always positive, and you don't have to struggle on that one. So h will be equal to, so I'll say 21 sine 30, I square it, that is 10, I'm getting 10 or 110.25. I divide that, open brackets, 2 times 9.8, then I close the brackets. So I'm getting 5.623 meters as my h. Now this h, I need to add it. So I have now 16 plus 5.6 623. So my h will be, I do plus 16 there. So my h is basically 21 point, my h is 21.625 meters. If you want, you can round it off and say it is 21.63. So now for part 3, that is the answer for h, being equal to 21.625 meters. That is the maximum height h. So now I can go back to part A to find now what? To find time, because I have the capital H. So the total time is given by this formula. I want just to simplify it. So the total time is given by time from t from A to B, which is v sine theta divided by g plus the square root of 2h divided by g. If you want, you can find it separately. You find v sine theta, you find this, and then you come and find that, then you come and add them. But what I'm going to do here is I'm going just to plug in the values. So what is v? V is 21 sine 30. I divide it by 9.8 plus the square root of 2. H is 21. So this formula, you can't use it without finding the h. It's not possible. I plug in like that. So what is it? 21 sine 30. Then I divide it by 9.8. That is 1.07. So I'm going to write it all the way to 4 like that. Then again, inside the square root, we have 2 times 21.625. Then the answer I find is 43.25 times or divided by 9.8. Then I'm finding 4.41. Then I square root this. So I'm getting 2.1007 like that. 77. So this answer, I'm going just to do and do plus 1.07143 like that. So the answer I'm getting is 3.1722222 seconds, but time in most cases we just leave it in one decimal place. So you can just say 1 point or 3.17 or 3.2 like that. That's the total time. Okay, so the t total is 3.2 seconds like that. So this one I'm trying to give you is very simple, and you have first to find the h. Okay, so you can't, in short, finding time, even if you use that other formula, you cannot find without finding the h. So the first part, I had to go to part 3 to find the h. I go back to part 1 to find the what? The time. Now let's do the last one, which is part 2 now. Okay, so part 2 is asking us to find the horizontal range. So range is given by Vx times t. But what is Vx? Vx is always V cos theta, just like that. V cos theta times t. The time we are talking about here is the total time, which is 3.2. So we can plug in the values. V is 21. Cos 30 degrees times 3.2. So the range will be equal to 21 cos 30 then times 3.2. So what I'm finding here is 58.19. So I can just say 58.2. 58.2 meters being equal to my range. Okay, so that is it for this type of trajectory. So one thing you need to remember is that you cannot find the time without knowing the maximum height. At the same time, you cannot find the maximum height without first finding this small h of the second trajectory. So you need to be familiar with the second trajectory, because for you to know this type of trajectory, we need first to focus on the second trajectory, where you need to know how to find the time, okay, from A to B, then also the h in that case. So that h is going to help you to find the maximum height, whereby you are going to add to the height of the building. So in most cases, you are going to be given the height of the building. Like in this case, they will give you the height of the building. Then if they give you the height of the building, just find that other height, then add. That is the maximum height. To find the total time, find using the square root of 2h divided by g, find that time. Again, find the time for the second trajectory, v sine theta over g, then add it. That is the total time. To find the range, you know that is v cos theta times time. The time is the one we are talking about, the total time. The same time you have found using that formula which I have given you. As simple as that. So let's now talk about question 3b, which is saying, which is under rotation, work, energy, and momentum. Yeah. Yes. So here is a question. So the question is saying a hoop of radius 0.06 meters starts from rest and rolls down a slope without slipping. But A, find its linear and angular speed when it reaches a point of 0.5 meters vertically lower than its starting point. And we have been told that inertia is given by mr squared. Okay. Then part 2 is saying find the linear and angular speed in part 1 above if the slope were perfectly smooth so that the hoop just slipped and does not roll. Now I want you to understand one thing. So let's come up with an incline. Okay. Let's come up with an incline. So this incline, we have been told that the distance here is 0.5, the h meters. Okay. Then the disk is now rolling. So as it is rolling, it has got the radius. We have been told that the radius is 0.6. So it is rolling until it reaches down. So one thing we should know, guys, is that we have got 2 points here. We have got point A, where it started from, and point B, where it landed. So this is the conservation, like conservation of energy, not conservation, but conservation of energy, where we say the mechanical energy at point A should be equal to the mechanical energy at point B. What do I mean? The mechanical energy is the addition of all the energy which you have at that particular moment. Now, in this case, we expect to have 3 energy. We have the potential energy, the kinetic energy, translational kinetic energy, and the rotational kinetic energy, because it is rotating. So when something is rotating, we expect to have rotational kinetic energy as well. So we have got 3 energy: potential energy, translational kinetic energy, and the rotational kinetic energy. So when I add these 3 energy, I'm supposed to get mechanical energy. Now there we go. Meaning that I'm going to have mechanical energy at point A, I need to have 3. So I have got the potential energy at point A, kinetic energy which is translational at point A, okay, kinetic energy which is rotation at point A, being equal to the same thing at point B. I need to have the same thing: potential energy at point B plus kinetic energy translational at point B plus kinetic energy rotational at point B. Now, let's analyze this thing. The question is saying it started from rest, meaning at this point the velocity was zero. So if the velocity is zero, I don't expect to have kinetic energy at point A. So therefore the kinetic energy will be cancelled out because kinetic energy depends on the velocity. Okay? Now let's go to point B. When it reaches at point B, it stopped. Okay? When it reaches at point B, it was just moving, but the h was zero. So if we don't have h, then the potential energy depends on h, then potential energy is zero. Now we have remained with potential energy at point A being equal to kinetic energy, the translation at point B, and the kinetic energy rotation at point B. Let's see. Potential energy is mgh. Translational kinetic energy is the same kinetic energy, mv squared. Rotational kinetic energy is given by half inertia times angular velocity squared. Let's plug in the values here. Kinetic energy or potential energy is this. This is going to be given by half mv squared. Then this is given by half inertia angular velocity squared. We do not have m, and we can clearly see that m. So before we go there, we do not have m, so we need to find a way on how we are going to cancel out m. So the first question is the linear speed. The linear speed is v. The angular speed is w. So let's first find the angular speed. Let's first find the linear speed. Then we'll come back and find the angular speed for part A. But we've been told that inertia is mr squared. So I'll replace inertia with that. Let's also try to find a way on how we can manipulate the w. So v is always given by wr. So to make w as a subject of formula, divide both sides by r. So w is v over r. So I'm going to replace where there is w with v over r. So I'll come here and say mgh being equal to half mv squared plus half. The inertia is r squared. Then this is squared again, so it's going to be v squared over r squared because w is squared. At this point I can cancel r. Okay? So if I cancel r, I'll remain with mgh being equal to half mv squared plus half again mv squared. But we can clearly see that we can see mass everywhere, so I'll cancel mass. If I cancel mass, the only thing I'll end up having now is gh being equal to half v squared plus half v squared. My goal is to find the v. So half plus half, I'll end up having 1. So this is going to give me 1. Okay, I'll have just v squared. So when I do that, I'm going to get the square root. So v will be equal to the square root of gh. If we are to plug in the values, what are we going to have? So we're going to have v being equal to the root of 9.8 times h is 0.5. So v will be equal to 9.8 times 0.5. So 4.9. The square root of 4.9 is 2.2. 2.2135. 2.21359 meters per second. Now I'm going to round it off to just 2.1. The reason why I'm going to leave it in 2 decimal places, everything here is in 2 decimal places. You can clearly see. So I'll leave it in 2 decimal places. So you check the question the way you have been given. If it has been left in 3 decimal places, leave the answers in 3 decimal places. It's fine. Okay, so that's the linear speed. Now I want you to understand another thing here. Let me just get rid of this. We have found that v is equal to 2.21 meters per second. The question was, and is still saying, find its linear and the angular. So this is the linear speed. Let's find the angular speed. So the angular speed is w. Remember we had this formula here. V is equal to wr. So we have now our v. Let's make w as a subject of formula. Divide both sides by r by r. So w will be equal to v over r. So we have 2.21 divided by the radius is 0.06. Therefore, the angular speed is going to be 2.21 divided by 0.06. So the one I'm getting is 336.8. 36.83 lad per second, because the SI unit is lad per second. So I'm done with part A. Now part 2 is saying find it's the same question, but they have changed. If it was not rolling, if something is not rolling, we don't expect to have rotational kinetic energy. We are going just to have translational kinetic energy. If something is rolling, we have kinetic energy translational and kinetic energy rotational. But in this case, this is not rotating. That's why the question is, just a minute here, the question is saying, find the linear and angular speed in one above if the slope were perfect smooth so that the hoop just slipped and does not rose. So we get rid of this. So we'll do the same. The mechanical energy at point A will be equal to the mechanical energy at point B. At point A, I have potential energy at point A plus kinetic energy at point A. Now, this kinetic energy is translation. I do not expect to have rotational because the object does not, it's not rolling. It was smooth, so it was just going without rolling. Should be equal to the potential energy at point B plus kinetic energy translational at point B. At point A, I do not expect to have kinetic energy because it started from rest. At point B, I do not expect to have this. So therefore, I'll end up having this. So is mgh being equal to half mv squared. M and m can cancel out. So have g h being equal to half v squared. I want to make v as a subject of formula. I'll do times 2 to get rid of the half. So it will be now 2gh being equal to half times 2 is v squared. So v is equal to the square root of 2gh. Okay, so v will be equal to, let's plug in the values, 2 times 9.8 times the h 0.5. Therefore v for part 2 will be equal to 2 times 9.8 times 0.5. 9.8. 9.8, the square root of 9.8 is 3.13 meters per second. That is the linear speed. Now, I want you to understand this. The question is asking us to find two things. The linear, this is the linear speed, the angular. If the object is not rotating, it is not rotating. So the angular speed is 0 because it's not rotating. So it's 0 rad per second because the object is not rotating. I cannot start using the formula which I use for part A, because part A the object was rotating. So part 2 is not rotating, so the angular speed is 0. Okay, so that is it for this interesting question, guys. I know that you are enjoying this video, and in today's session, like you have seen, guys, is something that is interesting. Yeah, so then you can actually access all the past paper videos from our website. So if you log in, then click on physics, we have the full topic videos, and I've also solved other questions that can help you to understand more on each topic. Then plus the past papers. So I have the past papers for 2024, yeah, 2023, 2022, 2021, and 2020, as well as from 2014 to 2021. Remember, physics, most of the questions they just repeat, or it's the same concept, but when you understand a certain concept, it's going to be easy for you to solve that other concept. So if you look at these papers, in most cases they have been repeating questions. So watching these videos, it is a guarantee that you have already cleared. So yeah, so without wasting much of your time, register with us at a promotion fee using the link in the description. If at all you're not going to be able to find the link, just go on Google and search Transcended Institute. Then you can create an account. If at all you don't have an account, then you can pay using the website. If at all you are going to have challenges, down here, if you look at, you can either text us using this email address, or you can call us using this number, or you can just go direct on WhatsApp here where it's saying WhatsApp. If you click here, it will take you direct to our WhatsApp. Okay, then you can get in touch with us. Thank you. Let's continue with our video now. So we continue with question 4, that is question 4a. So the question is saying a pool ball A of mass ma being equal to 0.4 kgs, moving with a speed of va, which is 1.8 meters per second along the positive x-axis, strikes another ball B initially at rest of mass mb being equal to 0.500 kgs. The collision results in ball A being deflected off at an angle of 30 degrees with respect to positive x-axis with a speed of 1.1 meters per second. So there we go. It's important for us. The first question saying write down the equations expressing the conservation of momentum in x and y direction separately. Solve the equation, part 2. Solve the equations for the speed of ball B after the collision and angle theta B. Now, it is very important for us first to come up with what we have been given, and then later on we see how we can solve it. So I'll come up with data here where we can clearly see that we've been given the MA being equal to 0.4. We have been given the VA initially, which is initial velocity 1.8. We have been given MB 0.5. So VB initially it was at rest 0. Then VA final we have been told is 1.1. The theta A we have been told is 30 degrees. But VB final we don't know. So allow me to use final to be the I'll be using final to be prime. So I'll use it as a prime like that. So I'll say VB prime, I don't know. Again, the theta B, I don't know. From the question here, we can come up with a free body diagram. So the free body diagram will go like this. We have two ball A and ball B. That is before collision. before collision. After collision, this is what is going to happen. This is going to be deflected there, this other one will be deflected there. So I'll have my two guys here, this one being equal to VA prime, then this is MA, this is MB. So this is VB prime, theta A and theta B. So let's start with x-axis. In x-axis, the first thing what happened was the object was just moving in a straight line before collision. So it will be MA, VA, VA initial plus MB VB initial being equal to MA VA prime now in x-axis, because now we have two things which are happening. So we have this. So this is V, meaning this is my Vx, this is my Vy for the first part, which is Va. Okay, then plus MB VB prime x. So in x we are using cos, so I'm going to replace this with V cos theta. And initially it was that this MB was at rest, so we don't expect to have initial speed. That will be cancelled. So I'll remain with MA VA, then MA VA prime cos theta A plus MB VB prime cos theta B. That is, now we are writing the equation in x direction. So we are writing the equation in x direction. Let's see what we're going to have. So MA is 0.4 times V1 VA initial 1.8. So being equal to again 0.4 VA final, which is prime 1.1 cos 30 plus MB is 0.5, so VB prime cos theta B. So if we punch 0.4 times 1.8, so I'm getting 0.72, then 0.4 again. So first I'll say 1.10 cos 30. The answer I find times 0.4, so it's 0.381. Okay, so 0.381 plus 0.5 VB prime cos theta B. Now I'll shift this to go to the other side, which is going to be 0.7 minus 0.381 being equal to 0.5 VB, so it's prime cos theta B. So if I do minus 0.7 minus that one, I'll be able to get 0.3389, so which is the same as 0.34 being equal to 0.5 VB prime cos theta B, like that. So that's the equation for y direction, of which now I can put it, I can get rid of this because I don't have enough. Okay, I can just put it here. I'll put it here. So we have, or the best thing I can do, I can start writing 0.5 VB prime cos theta B being equal to 0.34, like that. Now we get rid of everything here. So we go now to y direction. Now in y direction we have to be very much careful. In x everything was positive because they were both going in this direction. But y, for the second part, the v2, the vb, it is going in negative x or negative y axis. Then this is in positive. But this object before collision, it was not moving in y direction. It was just in x. You can clearly see that the line I had to draw here is just one. So therefore, in y direction, the equation which we expect to have is first 0. Then now we have m a v a prime now in y. So this is this one now. But this one is going to be negative because it's going toward negative y axis. So it will be minus mbvb prime y. So it will be 0 being equal to ma prime sine theta. So theta a minus mbvb prime sine theta b, like that. So shift one of these guys to go to the other side. You can shift any. Okay, so it is going to be mava prime sine theta a being equal to mb vb prime sine theta b, like that. So now at this point I can plug in the values. So ma is 0.4, va final is 1.1, then sine the angle is 30 being equal to, this is 0.5. I don't know what vb is and I don't know what the angle is. So we have 1.1 inside there, 1.10 sine 30. The answer I get times 0.4, which is 0.22. 0.22 being equal to 0.5 vb prime sine theta b, like that. So what we can do, I can just put this, I can start writing this side to say 0.5 vb prime sine theta b being equal to being equal to 0.22. So this is going to be my equation for y-axis. So the equation for x separately, the equation for y separately, done. But 2 is saying solve the equation for the speed of bob b. So let me just write this one here. 0.5 vb prime sine theta b being equal to 0.22. So this is equation 1 and that's my equation 2. Done. So now to solve this, you put the equation which is having sine on top, you divide it by the equation having cos. Okay, so in this case I'm going to say 0.5 vb prime. So the one having sine is the one I'm going to put here on top. Okay, being equal to 0.22. Then I'm going to divide it by, I'll divide it by the equation having cos. I want to make it a straight line. So again I have got 0.5 vb prime cos theta b being equal to 0.34, like that. The next thing what we're going to do is 0.5 and 0.5 can cancel out. VB and VB can also go out. So then I'm going to remain sine theta over cos theta. Sine theta over cos theta is tan. So I've remained with tan theta being equal to, if you want you can divide there, or you can just leave it the way it is. Then you come later and so I'm trying to first find the angle theta b. Therefore theta b will be equal to the tan inverse of 0.22 divided by 0.34, like that. So let's see, theta b is going to be equal to shift then tan open brackets 0.22 divided by 0.34. So the angle I'm getting is at 2.9. The 2.9 degrees, of which I can round it off and say is 33 degrees. That's the theta. So again the question continues to say we need also to find the velocity of VB final. So now that we have, it's going to be easy now, because we have these two formulas which we made. So it's going to be easy. So you can choose any formula. I'm going to go with the first one. So the first one is 0.5 VB final cos theta b being equal to 0.34. So just plug in the theta, we see. So if I plug in the theta will be 33 being equal to 0.4. Then just divide both sides by 0.5 cos 33. Even here 0.5 cos 33. So these will cancel out. This will cancel out, and that is going to cancel out. So the VB, which is the final, so we have 0.34. You divide it, then you open the brackets. So you say 0.5 cos 33. So I'm getting 0.81 meters per second. If you want, you can use the one for sine. You end up having the same answer. You can go and try it out. You end up having the same answer. Okay, so that is it for question 4A. I know that you are enjoying this video, and in today's session, like you have seen, guys, it's something that is interesting. Yeah, so then you can actually access all the past paper videos from our website. So if you log in, then click on physics, we have the full topic videos, and I've also solved other questions that can help you to understand more on each topic, then plus the past papers. So I have the past papers for 2024, 2023, 2022, 2021, and 2020, as well as from 2014 to 2021. Remember, physics, most of the questions they just repeat, or it's the same concept, but when you understand a certain concept, it's going to be easy for you to solve that other concept. So if you look at these papers, in most cases they have been repeating questions. So watching these videos, it is a guarantee that you have already cleared. So yeah, so without wasting much of your time, register with us at a promotion fee using the link in the description. If at all you're not going to be able to find the link, just go on Google and search Transcended Institute. Then you can create an account. If at all you don't have an account, then you can pay using the website. If at all you are going to have challenges, down here, if you look at, you can either text us using this email address, or you can call us using this number, or you can just go direct on WhatsApp here where it's saying WhatsApp. If you click here, it will take you direct to our WhatsApp.